Good morning. Today I'm going to talk about inverses, 6-12. And this is pages 159 to 161 in your notes packet. Okay. So to find an inverse of a function, first of all, we're going to go through this activity on the first page. If you want, you can stop, fill this out, then we'll come back and talk about it. But I'm going to walk through it. Okay. F of -2. So you plug -2 into this function. 2 times -2 is -4 plus 4, you get 0. So this is the point -2, comma 0. Okay, now we're going to plug this point 0 into the g function. Okay, so we get 1/2 times 0 minus 2, we get -2. So that's the point 0, comma -2. So -2, 0, 0, -2. Okay. Now we're going to plug in -1 into the f function. 2 times -1, -2, plus 4 gives you 2. So that's the point -1, 2. Now we're going to plug the point 2 into the g function. 1/2 times 2 is 1. 1 minus 2 gives you -1. So that's point 2, -1. So we've got on the f function, we've got -1, 2. On the g function, we've got 2, -1. Plug in 0 to the f function, we get 4. So that's 0.04. Plug in the 0.4 into the g function, and you get 0. So that's 0.4, comma 0. So 0, 4, and 4, 0. Plug in the 0.1 into the f function. 2 times 1 plus 4, you get 6. 1, comma 6. Plug in the 0.6 to the g function. 1/2 times 6 is 3 minus 2. You get 1. So that's 6, comma 1. Okay. So what can you conclude about the points f and g? Okay, so for every ordered pair on f, the corresponding point on g, you would just have to switch the x and the y. Okay, so for every point x, comma y on f, there is a corresponding point on g where x and y are switched. Okay, and you conclude that f and g are inverses of each other. This right here is a property of inverses. For every point on a function x, comma y on one function, on the inverse function, there will be a corresponding point where you switch the x and the y. Okay, so we're going to graph the line y equals x on here, the line y equals x, and we're going to take a look at something. I'm just going to graph a dotted line here because this line's not part of our function. And now I'm going to plot these 8 points up above. I'm going to plot f, so -2, 0, -1, 2, 0, 4, and 1, 6. Okay, and I could draw this line. It's like that would continue. It's a slope of 2. So this right here is my function f. And that was point 0, -2, 2, -1, 4, 0, and 6, 1. That has a slope of 1/2. So a couple things you'll notice. This is my g function. Okay, so they will, if these two intersect, they will intersect on that line y equals x, which makes sense because if y equals x and you switch x and y, it's going to be the same point. So it should be able with f and g. Now what you'll also notice is that these are symmetric. These two functions will be symmetric over the line y equals x. So for each corresponding point. Let's take this one right here. This was 0, 4, and this is 4, 0. Those are your corresponding points. Okay, they're going to be the same distance from that line. They're mirror images of that line. Okay, so this point here, which was 1, 6, and 6, 1. Those, again, mirror images. They're the same distance from that line. Okay, they're mirror images over that line. Almost like I could fold this piece of paper right down this line, and this would line up exactly with this. Okay, almost like you made this thing horizontal. Okay, this would be a mirror image, a mirror reflection over that line. Okay, so the points of f of x are symmetric, or reflections. Let's just say reflections over the line y equals x. Okay, I think we'll do that here. So they are symmetric, and the points of g of x are reflections. Points of f of x. Points of f of x are okay. I think they're just reflections of each other. Reflections over the line y equals x. Okay, let's go to the next page. Okay, to find an inverse relation. So now if we actually have, so that was a case where we have the points on the function. If we actually have the function, to find the inverse, step one, really two quick and easy steps. If you can remember the steps. We're going to switch x and y. And then solve for the new y. And then you can write in function notation. Okay, so I first, to find the inverse relation for each function, graph the functions on your calculator and do the horizontal line to determine whether or not the inverse relation is also a function. Okay, but we're also going to go through these two steps. Okay, so this thing, f of x, that's just your y. Y equals negative 3x plus 6. I'm going to do step one here where I switch x and y. So you're not really doing any calculations here. The y becomes an x equals negative 3, and the x becomes a y. That's your first step. So this is y equals 1/5 x minus 8. The first step, you're going to, the y becomes an x, the x becomes a y, everything else stays the same. So this is y equals x squared plus 6. Step one, y becomes an x equals, that becomes a y, so y squared plus 6. That's your first step. Does everywhere you see an x turn into y? Everywhere you see y turn into an x. Okay, step two, you have to get that y by itself. So let's write it 6. X minus 6 equals negative 3y. Divide by negative 3. So we get the y equals, and we could do x minus 6 over negative 3, or you could say y equals, 6 minus x over positive 3, which is making that negative. Okay, multiplied by negative 1 over negative 1. And then function notation says that we would rewrite this as f inverse of x. Okay, so if f is written as f of x, f inverse is written as f inverse of x. That's how you say it. F inverse of x equals, let's say 6 minus x over 3. All right. If you want, you can try these. I'll work through them. Okay, we want to solve for that. So we've got x plus 8 equals 1/5 y. Multiply both sides by 5. Y equals, and that's going to be 5x plus 40. So that's going to be g of x. So this will be g inverse of x equals 5x plus 40. this one. Okay, we have to solve for that. So step 2, we're going to solve for the new y. X minus 6 equals y squared. Okay, so y is going to equal plus or minus the quantity square root of x minus 6. Okay, so when you type this in your calculator, let's write it as an inverse. So h of x and h inverse of x equals plus or minus square root of x minus 6. Okay, and you can type these all in your calculator and see what you notice. We are going to, well, okay, let's type in, these two are linear. When you have a line, as long as that line is not horizontal, then its inverse will also be a function. You can do the horizontal line test. We'll do one of these. Let's do this one, number B. Okay, so what you're going to do here, I'm going to just new document, add a graph. Graph the function 1/5 x minus 8. So we get 1/5 x minus 8. And then I'm also going to graph 1/5 x minus 8. Okay, so we need to see that a little better. So I'm going to change my window, menu, for window settings. I'm going to go, let's say, negative 20 to 20. Negative 20 to 20. You can see that a little better. Okay, now I'm going to graph the inverse, 5x plus 40. The tab button. Okay, and what you can see here, sometimes it's a little easier to see when you graph that line y equals x. So I'm also going to graph the line y equals x. Again, y equals x is not part of your function, but you can see that these are reflections over that line y equals x. Now this isn't perfectly square because it's kind of elongated this way, so you can't see it as well. But let's see if we can do a menu, window. You can do a zoom. Isn't there a zoom square here? Yep, zoom square. Let's see how that goes. Okay, so you can see it a little better if you do a zoom square, that these are reflections over that line. And if they intersect, they'll intersect here. This one is a function because it can pass the vertical line test. Okay, this one, its inverse will also be a function because it will pass the vertical line test. Okay, so both are functions. We'll say that here. Both are functions. Now let's look at this one. Okay, I'm going to just make a new graph. So we're going to graph y equals x squared plus 6. Okay, we might want to change that window a little bit. Let's go to 4. Let's go negative 15 to positive 15. Negative 15 to positive 15. Okay, I'm going to fix that. You can also just double click on that and then hit tab. It'll take you to the next one. So to positive 15. Okay, so there's that. Now I'm going to graph this one. And as you can see, if I'm going to reflect this thing over the line y equals x, let's type in y equals x. Reflect that this way. Notice you're not reflecting it straight down. You're reflecting it this way, as if you were to fold this paper on this line. And this point 0, comma 6 becomes the point 6, comma 0. And now it's going to open this way. Okay, so let's type that in. So we have to type in this. Now you can't type that all in one thing. So we have to first type it as y equals rad x minus 6, and then we need another one, y equals negative rad x minus 6. Rad x minus 6. And then y equals opposite of rad x minus 6. Okay, and you can see that thing. Let's move that out of the way because it's got two of them there. Okay, so this thing, notice that's kind of a hint. This thing's not a function. So this one we would say inverse is not a function. Okay, so one way you can think about this, remember how you test if something's a function, you do that vertical line test? Well, if you want to know if its inverse is going to be a function, you can do that by looking at the original function, but instead of doing the vertical line test, you could do a horizontal line test. So test if you take a horizontal line and cross through that function, are you going to hit at more than one spot anywhere? Because when you flip it over this line, that is going to be a vertical line. Okay, so if you hear of the horizontal line test, that's really testing if something's inverse is a function. Or you can simply find the inverse and again do the regular vertical line test. Okay, so this one over here, these were both lines, and if you did this one, these are both our functions. Okay, now let's look down here just to get the idea, sketch the inverse of each. Now we don't know the actual function, and so we're just going to estimate. So you could draw this line y equals x. This point here looks like 0, comma about 2.6, so that's going to become 2.6, comma 0. Let's look at that point here. It's almost 2, comma 4, maybe 1.8, comma 4. So that's going to be, 1.8, comma 5. So about 5, comma 1.8. That's going to look like that. So those are reflections over that line. Okay, let's do this one. Again, reflections over this line. If you can find a point, it looks like -1, comma 2. -1, comma 2. When you switch that, that's going to be 2, -1. -1, comma 2. 2, -1. It's going to be on the inverse. And let's take this point. That's 3, comma 0 becomes 0, comma 3. And then you can connect those. The inverse will look like this. And if they do cross the line y equals x, they should intersect there. Again, because any point on x equals y, your x equals your y. So when you swap the x and the y, it's the same point. Okay, now notice this one, they don't cross that line. So you're not going to see that point where they intersect. Okay, this one over here, let's draw the line y equals x. And this one's an interesting one, because if you reflect this over this line, it's probably going to be another parallel line right here. Okay, let's just double check. Let's take a point. Does it look like any of these points actually lie? So that's a point. At 0, 1.5, that would be 1.5, 0. Let's take another point. Let's go -1.5, 0 becomes 0, -1.5. You can see that. You connect those. Again, those don't intersect. They don't cross that line y equals x. Okay, now let's go to the next page. Find f of g of x. So this is kind of interesting. So you're going to take the g of x. This thing becomes the input into the f function. So f of 2x plus 8. Well, if I'm putting something into the f function, this entire thing has to fit in where x goes. So the f function says I take an input, multiply by 1/2, and subtract 4. So 1/2 times something minus 4. Now, if this is my input, I put the entire thing in there, 2x plus 8. Okay, so I get 1/2 times 2x is x, 1/2 times 8 plus 4 minus 4. What do you know? We get x. Okay, let's try this one. G of f of x. So now we're taking f of x and making that the input into the g function. So g of f of x is 1/2 x minus 4. Okay, so now I take the g function, which takes an input, multiplies by 2, and adds 8. Takes an input, multiplies by 2, and adds 8. Now this entire thing is my input, 1/2 x minus 4. So you get x minus 8 plus 8, and you simply get x, okay? Now, spoiler alert, okay, anytime you have f of g of x and g of f of x that ends up just being x, then your functions are inverses, okay? If f and g are inverses of each other, then f of g of x equals x and g of f of x equals x. Okay? Now, why does that happen? Think about it. Think about what inverse functions will do. They undo each other. Okay? Kind of like an inverse operation. If I take a number x, I multiply by 5, and then I do the multiplicative inverse, I divide by 5, I'm back to where I started. Okay? So if I take a number, any input x, I put it into the g function. G does a bunch of calculations to it and spits something out. You get an output. Now I'm going to take that output and put it into the inverse function that's basically going to undo everything that the g function just did, and it spits out the original input. Okay, same thing here. Put an input into the f function, does some calculations, spits out an output. You put that output into the g function, and it undoes all those things. You can kind of see that happened here. Okay, we put in -2 into the f function. It spits out 0. Now you put 0 into the g function. It undoes everything, and you get back to that original -2, the -2 you started with. Put -1 into f, it spits out a 2. You put in 2 into the inverse, and it undoes everything, and you spit out that original -1. Okay? So do we think these are inverses of each other? Yes, they are. Okay? So we could graph these. 1/2 x minus 4. We can see this by doing by plotting them, and we can see that they're reflections over the line y equals x. 2x plus 8, slope of 2. They should, if they intersect, which they will, they should intersect on this line. And that point right there is on your line. -8, -8. Okay? You can see that they're reflections over that line. Okay, one last one, exponential function. So f of x equals 2 to the x. Let's plot some points. So in your f function, x and y, let's put 0. Let's do 1, 2, 3, -1, -2. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. 2 to the -1 is 1/2, 2 to the -2 is 1/4. Okay, -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. Okay, so you've got this function f that looks like this. Okay. Now the g function. So we're going to do this two ways. X, y. Okay. Now we're going to take each one of these. What did I write there? That's not negative. That should say 1/4. Okay, we swap the x and the y. So on the inverse function, I'm going to call this g. This is called that f inverse of x. Okay. Then the inverse, all the ordered pairs are switched. So 1/4, -2. 1/2, -1. 1, 0. 2, 1. 3, 8. Okay. So 1/2, 1/4, -2. 1/2, -1. Sorry. 1/2 negative 1, 1, 0, 2, 1. Well, not 3, 8. What did I do? No, that's right. 1, 0, 2, 1. Sorry. This should be 4, 2, and 8, 3. I'm switching the x and the y. Okay, 4, 2, and 8, 3. And so we've got these points here. And you've got the line y equals x. Okay. Now, one more thing that's really cool. Let's take this. Let's go through our 2 steps up here. Yes, up here. Okay. Let's go through our 2 steps. So we've got y equals 2 to the x. Step 1, swap x and y. X equals 2 to the y. Solve for the new y. Okay, how do we get that out of there? Well, we have to use a log. So this is going to be, rewrite this as a log base 2 of x equals y. You have the y by itself. So f inverse of x is equal to log base 2 of x. There's our inverse function. Guess what we just graphed? We just graphed a log function. Okay, this is an exponential function. Exponential and logarithmic functions are inverses of each other. Here's f, y equals 2 to the x. That's this one. This one right here is y equals log base 2 of x. All right. Thank you for watching. Hope you enjoyed that video.